Let's deal with our next concept when it comes to heat and energy, and that is how substances transmit heat. And the first way is through conduction. Conduction works best in solids because the closer particles are, the quicker it can transfer heat energy this way. The more tightly packed the particles, in other words, the density, the better the rate at which a substance conducts. And the mechanism for conduction is the direct collision of particles, almost like a domino effect. So here's an animation. The particle, we heat this particle and it vibrates and bumps into neighboring particles, and that causes heat energy to move along in the substance. So the closer these particles are packed together, the better they are at conducting heat energy. And so if this was a different substance with a higher density, then the particles would be even closer to each other, and therefore heat energy could transfer even faster. So metals have electrons that are very loosely bound to the atoms. These electrons can move easily and can rapidly pick up energy. Metals are good conductors. Wood and plastic are good insulators. They don't have loosely bound electrons and poor conductors. Air is a poor conductor. If you stand in the sun on a cold day, you're shielded from the wind, you stay pretty warm. Snow is a poor conductor because there's lots of spaces between snow particles. Water is a little bit better. We'll deal with convection later. So let's talk about why in your house, if you put your foot on a marble slab or marble floor versus carpet, which one feels colder? Well, this one, the marble, feels colder and the rug feels warmer. But the house is the same temperature. So how is that the case? Well, your foot is 37 degrees Celsius approximately. And so what happens is the marble slab conducts heat away from your foot quicker, therefore cooling it down faster. Whereas the rug is a good insulator and it doesn't conduct heat away from your foot as quickly. Here's a neat little device. So this is a conductometer, and we could put tacks with butter on the ends of this and then heat the middle of it. And when we do, heat is conducted from the center out towards the ends and will melt the tack and fall off. So these are all metals. The metal with the highest density is probably going to conduct heat quickest, and the tack will fall off fastest. We did this lab called the butter test, and what did we find out? Well, we took a cup of hot water and we placed 1, 2, 3, 4 substances. We put a stick of butter on the end of each of the substances, and heat from the hot water was conducted up the strip, causing the butter to melt and fall into the bottom. And what happened was copper should have been the first substance to melt the butter, then iron, then aluminum, and then the plastic was the worst conductor when we did the butter test. Let's look at this video clip on conduction.
If you stir a boiling liquid with a plastic ladle, after a few moments, the ladle will become quite warm. The same will happen with a wooden ladle. And a ladle made of metal can even become too hot to handle. This is because the heat from the boiling liquid is able to travel up the length of the 3 ladles quite slowly through plastic and wood, and very fast through metal. But how does heat manage to do this? How does heat travel through things? Well, when the hot liquid heats up the end of each ladle, its molecules, or in the case of metal, its individual atoms, start to vibrate more rapidly. And when the heated molecules, or heated atoms, vibrate faster, they start bumping faster and faster into their slower neighbors, causing them to speed up in turn, and bump into their neighbors, and so on all along the ladle. In this way, the increased speed of vibration, and therefore the heat, is passed on from molecule to molecule, or from atom to atom. It's like a row of dominoes knocking each other over. And this domino effect, which leads or conducts heat through any substance, is called, naturally enough, conduction. Non-metals, such as wood and plastic, conduct heat quite slowly. They are bad conductors of heat. In contrast, all metals conduct heat very rapidly. They are good conductors of heat. That's why the witch with the metal ladle got burned. But why is heat conducted so much faster through metals than through non-metals? Why are metals good conductors? What's their secret? Well, the secret lies in the fact that there's something very peculiar about the atoms in metals. We know that all atoms consist of a nucleus with a number of electrons whizzing around it, as in this very simple model. And we also know that the nucleus exerts a force of attraction on these electrons to make sure that they don't go wandering off all over the place. But if it were possible to look very closely at a group of atoms in the metal ladle, we'd see something like this. There are a lot of electrons that don't seem to be attracted to any nucleus. They're shooting about extremely rapidly in all directions. It's like this in all metals, in fact. They all have these free electrons, which are quite independent of the atoms themselves. Now look at what effect free electrons have when the end of the metal ladle starts to get hot. Not only do the atoms start to vibrate faster, but the free electrons also speed up and begin to move faster still, colliding with the atoms more and more often and with more and more force. And each time a free electron bounces off an atom, it causes that atom to vibrate a little faster. Imagine if the atoms were pins in a pinball machine, and that each of the free electrons were one of the pinballs. Each time a pinball hits a pin, the pin lights up, just like an atom vibrating faster. And the more rapidly the pinball moves, the harder and more often it bounces against the pins. If you could fire dozens of pinballs simultaneously, you'd be lighting up the pins like crazy. You'd be producing the same sort of effect that occurs when the metal ladle is heated. Only in the case of metal, of course, there are millions and millions of free electrons to speed up the vibrations of the atoms, and therefore speed up the spread of heat. And that's the secret of why metals are such good conductors. Much better than plastic or wood.